My name's Cameron. Work at LexisNexis. I'm a tech lead on a product called NewsDesk. It's media management, social media analytics kind of stuff. Pretty good fun. We do a lot with JavaScript, a fair amount with React, like Alan was saying, and over the years we've had occasions to do a lot of refactoring over hundreds of files where we need to take some syntax and change it into some slightly different syntax, and we've done the take 10 days to do that, and it's really boring, and you hate your life for 2 weeks. Eventually, we stumbled onto Codemods, and it's pretty good fun. It makes you feel sort of like a superhero when you're changing hundreds of files with a couple hours worth of work, and you don't want to die. So I thought I'd share it with all of you. Anyway, so what exactly are Codemods? So basically, it's JavaScript code that you write, and it's going to, in turn, make changes to your other JavaScript code. So think of it, writing code, or writing is probably a little bit ambitious. Code, changing code. And then kind of the neat thing is they use the abstract syntax tree. And so I'll get into that in a second, but basically that means they kind of understand the code. They understand the syntax. Probably all of you have at one point, probably a lot of points, tried to do large-scale find replace, and eventually you get fancy and you start using RegEx and maybe some capturing groups, and that works okay. Some things it does not work okay for, and things get pretty messy and you miss a whole bunch of stuff and you get pissed off. So Codemods are pretty good at that. Because with the AST, they can kind of understand the code. The white space doesn't matter, whether you're using foo.bar or foo bracket quote bar. It doesn't matter. It's all the same.
I assume you're going to explain what the AST is.
I will, yeah. So the AST, abstract syntax tree. So obviously with JavaScript or most languages, there's a very specific syntax that you need to follow, and then a tool, I think we're using AST-Types, can parse all that and breaks it down into basically very specific types that are predefined. And the cool thing is then instead of dealing with text, you're dealing with predefined objects that have types and names, and there's this tree relationship, so you can say, well, the program has lines, and the line might be an assignment or an import statement, and then an import statement breaks down to, these are not the exact names because I can't remember them, but the import statement breaks down to the actual import keyword and the variable name that you're assigning it to, and the right-hand side, which is the actual thing that the module you're importing from, and it gets very, very detailed, which lets you do really powerful stuff. Getting started is actually pretty easy. So it's easy to think that this is complicated stuff, and maybe you see the kind of things that Codemods can do for you, but if you're worried that it's complex and you can't do it, then you won't bother. But it's really simple, and I'll walk through a couple examples today so you can see how true that is, even when you're writing your own. All right, so quick overview of the necessary tools. Whether you are using open source existing Codemods or writing your own, you're going to use tool called JSCodeShift. So this is an NPM module, so you can NPM install it or yarn install it globally, and then run your Codemod script using JSCodeShift. So JSCodeShift is a script runner, so you're going to give it your Codemod, and then it handles all the bootstrapping of loading up all the source files that you want to modify. It tears through them, opens up the source, and then throws them at your Codemod script. And then your Codemod script only needs to worry about that one file, the source, and then you return the modified source after modifying the abstract syntax tree. And then JSCodeShift takes care of writing it back out to the file on your file system. And then it's also a wrapper around, I mentioned AST-Types. That's what gives you sort of the wrappers around the abstract syntax tree and lets you work with that reliably and understand the relationships between elements and then recast, which is what gets it from source to the AST and from the resulting AST back to source code. And then I mentioned you're going to use JSCodeShift regardless of where you get your code mods. But if you can't find an existing code mod for whatever it is you're trying to do, you'll probably want to use ASTExplorer.net. And what that gives you is the ability to explore ASTs, which is kind of mind-blowing there with a name like ASTExplorer. And I'll use that in a second to kind of show you around these JavaScript ASTs. And then it also has sort of JSCodeShift built in, and you can prototype your transform scripts on the fly, sort of like a code pen sort of thing, but for code mods. All right, so before we get any farther on slides and things, because they're boring, I'm going to jump over and show you JSCodeShift. Kind of the basic setup that you get with ASTExplorer. They have a bunch of different options, but if you show up here on your own, they won't have them pre-selected. Make sure you select JSCodeShift from the transforms, and then probably JavaScript is the default here. So first, let's just briefly talk about the AST. So look over here. You got program at the top, and then there's this body underneath that. And then, as you can see, as I hover over different components, it'll highlight the relevant bits that part of the AST, that particular node, relates to in the source code. So, if I hover over the function declaration, you see the print tips gets highlighted and so forth. And you can see as we drill down, things get more and more detailed, more and more low level. That one's kind of boring. Let's look at the function declaration. So there's the body of the function that goes into the expression statement, and it gets quite low level. It goes on a couple more levels here. And then we'll talk in a little bit more detail about this later, though I know I have limited time. And then down here in this lower left window, they have a simple example code mod. And what this one does is it basically takes all the identifiers in the example input file on the upper right, and it reverses the identifiers. So if you look at it over here, tips turns into spit. I'm not going to try to pronounce that. Print tips gets reversed. Everything gets reversed. And all in only this much code. Pretty cool. Simple example, and then you can do some pretty neat things with that.
Let's say there'd be some limitations, especially with JavaScript, in the sense that, since you can do kind of dynamic property accessing in terms of, you could build a string and then say, I want to get this property off an object. Knowing that at static analysis time, I'm assuming there's only, I guess, because you can always do some super devious stuff in JavaScript to the point where, you try to, flip all the identifiers that, especially since you can have identifiers appear from other scopes, if it's included from a different file, it won't know that it's related to this one. I'm assuming, with your experience in this, have you run into issues where you did the code shift and then you found out things broke?
Sure. So, I said it kind of understands the code, but you're right, that's at a syntax level, so it doesn't understand so much the logic of, well, this module depends on that other module. You can run it across, you specify sort of a glob pattern, and you can run it against, tons of files in your project. So if you, ideally if you changed the name of an export in this module, you'd be also changing the name of all the imports and all the other modules that use it. But certainly things can get weird since it doesn't work at runtime.
Right.
Absolutely. And sometimes, we've seen where it's a 90% solution or an 80% solution, and it gets most of the tedious work out of the way, and then we kind of polish off the rest ourselves. Does that sort of answer the question?
Yeah.
Okay, right on. Any more?
Can you do additions, or is it really basically limited to replacements?
Oh no, you can you can add stuff, remove stuff. So you basically mutate that tree as long as you can bolt stuff onto the abstract syntax tree. and then you just return the root of the tree, and then JSCodeShift gathers all the stuff underneath it. And there's plenty of helpers and stuff for doing that, so you're not painstakingly typing out the JSON to make it happen. All right, so back to my ridiculously sexy slideshow. All right, so mentioned I'd like you all to kind of get a feel for what this can do. So on the open source Codemods side, so some examples are library upgrades. It's kind of common nowadays if you upgrade React or you upgrade, underscore or something, maybe the syntax has changed between versions, and the library maintainers or somebody else will provide a code mod to kind of upgrade the syntax. Another one is JavaScript syntax changes. So one thing that the code mods can do is take your object.assign calls and convert those into object spread syntax. That'd be a complete disaster with RegEx, right? Library migration, so if you go from React to Preact, there's code mods for that. Module format changes, so we used one to go from AMD modules to common JS modules and then to ES6 module format. And then surprisingly, language migrations. I've seen code mods that'll convert CoffeeScript to ES6, which is kind of cool. All kinds of things out there. Search around, see what you run into. And then on the custom side, you don't find something that meets your need, don't shy away from doing your own. So you might do something as simple as renaming variables. If you've got just one file to change, obviously it's not worth it. But if you want to change some variable that's used in hundreds of files, code mods will absolutely help you with that. Or bulk changing module aliases. We had this situation. We had some silly alias names used across hundreds of files, and code mods made short work of it. This is a fun one. If you want to find usages of, we used it actually for React props for a given React component. But if you want to find what's using a given property of like a checkbox component, for example, run a code mod and console out the results. The alternative is you look for, bracket checkbox in your whole app and find, 900 examples. That's no good. Import changes, lots of odds and ends. So the idea is just kind of use your imagination and see some example code. All right, so this would be stupid code, but just for example purposes. But one thing that's kind of nice about AST-Explorer is it doesn't care what this input looks like. So I've got 2 returns in a row here, which would be stupid. But the nice thing is you can use this to kind of prototype several different variations, because you might create a code mod that works great for, let's say _.unique, but it doesn't work so great for the bracket with the strings approach, right? So the idea is to throw a lot of different examples in here for your prototype. So what we're going to do here is, hypothetically in our project, we decided we don't want to do import underscore from underscore anymore, and we want to turn all these into essentially import map and unique and for each and sort and so on from underscore, right? Because that's better. So we've got, what are the changes we're going to have to do here? So we're going to have to get rid of these and replace them with something that looks like this, right? Note that we have 2 here, which is possible. I might have imported to a variable that wasn't the actual underscore symbol. That's important. And I might have other things that I've done named imports with. And I might have, again, done another import that actually used the underscore character. So we want to replace those with something that looks like that. And then actually in the code, we need to, of course, replace our underscore.unique with just unique. And our underscore bracket for each with just for each. And so on. You get the idea. Okay. All right, so what we're doing here is we're going to take our source and throw it through JSCodeShift. So you see API is, that's passed in by JSCodeShift, and then you call the JSCodeShift, or you get the JSCodeShift object from it. Typically, the convention is you assign that to J just for ease of use, and then you call that to get a wrapper and convert all the source into an abstract syntax tree. And we'll go ahead and assign that to our root node here. If we were to console log that, you'd see that's a collection. A collection with our file as the root, and then there's a program underneath that, so you see that's a collection of nodes. All right, so now, so what we want to do is first get, I'm going to delete this here. First, we're going to get our list of kind of global object names. So we want to get that Lodash, and we want to get the, used to be Lodash. I'll change it to underscore. I'm actually going to run this through our project so you can see all the deltas, and it was originally Lodash, but we don't use Lodash, so I had to change it to underscore. All right, so we want to get the actual underscore and then the underscore character so that later we can go through and find these and change them. So that's what's going on here. So the JSCodeShift find method, you pass in the type of the node that you're interested in. So if we click over here, we're going to, we look in our abstract syntax tree explorer over here, we see, we're looking for the import declaration, which is this entire import line. And then you can pass in, as the second argument here, some kind of qualifiers. So we only want import declarations where the source value, that's the actual import module name, is underscore, and then where the specifier type, that's this or this, is an import default specifier as opposed to the named import. Let me go ahead and console log that. I mentioned debugging does not work. So you have to console log everything. So there's only two of these. So we're going to get the underscore and the underscore character. Then further, once we've got the import declaration, we want to further find the import default specifier. And that's the actual underscore character and the underscore text. So if I were to move. If I were to move this down lower, I still have two, but now the value is the actual identifier. So underscore in this case, and it's going to be the underscore character in the second one. All right, and then basically we're going to actually get the name of those. So now we wind up with strings, underscore, and the underscore character. Let me just console log that so you can see how we're progressing here. So you see what we got in object names now? Mm-hmm. All right, any questions so far? Is it kind of making sense, or is it too vague?
Yep.
Okay. I'm going to have to hurry this up so that I don't run over time. All right, so next thing we want to do, remember we wanted to replace the statements in the body of the source. So the way we're going to do that is to go through our object names, and for each one of those, we're going to find any statement that uses, whatever the object name was, underscore, or the word underscore here, dot something or bracket something or whatever. and then we're going to replace it. So, walk through some of these we've already seen now. So for each, if you're into JavaScript, you're familiar with that. So here we've got the object name, so that's going to be underscore or the underscore character. So we're looking for at the root of the program, and we're finding anything that's a member expression. Let me show you where that came from. So we click on our source, and it gives us in the AST over here an identifier. So that's this unique, in the property field. In the object field, it's the underscore, and the parent of both of those is this member expression. And if you were doing this yourself at home, you would click on each of these, and you'd see that all of these, no matter what the syntax is, they're all member expressions, just with different identifiers. And so you say, okay, well, we want to find all the member expressions, and we're going to manipulate those. And we, of course, only want to find the member expressions where the object, the leading part here, is underscore or the underscore character or whatever the particular value is in object names that we're looking at. And then for each one of those, we're going to here, we're basically getting, to abbreviate this, the name of the property. So unique, or for each, or sort, and then we're going to do our replace. So the path here is the AST kind of wrapper around the member expression, and we're just going to replace that whole thing with a new identifier. If you look at the member expression, the property is an identifier with the name sort. We're going to replace it with a new identifier. That's just sort. So you can actually see this working. Let's return root node.toSource. Okay, so now over here you can see we're using unique, we're using for each instead of underscore for each, we're using sort instead of underscore sort. So we've trimmed that off, and then I'm aware of the fact that I'm running short of time, so maybe I won't talk through all of this, but the next thing to do is replace the imports themselves. Now, one of the exercises was going to be, okay, well, of course we don't want to replace both of them, so we'll wind up keeping track of have we replaced it yet in the for each, and if we have, then we won't replace the second one. Right. That's pretty simple JavaScript. So once you get in there and you're doing it yourself, it'd be fairly straightforward. But basically, we're keeping track as we go of all the functions that we use, and then we replace all of the imports that we see that are for underscore with the full list of underscore properties that we wound up using in our source code. And then for fun, let me show you how to run this with JSCodeShift. So this is on their GitHub page, of course, but just so you see, it's pretty easy. You wind up providing your actual code mod, underscore imports, and then you give it maybe some files to ignore, which is important in our case, and then you give it a series of glob patterns here. There can be many. And so I mentioned it's a runner, so it takes care of loading up all these files. It'll do them 50 at a time, loading up the source, throwing it at your script, so you only have to deal with one of them, getting the results and writing them back out to the file system. And you can see it does 50 at a time, so it's pretty speedy. Show you if I drop some React in here. It knows what that is. JSX identifiers, JSX elements.
Yeah. Cool.
I'm sure there's limits to it, but I said there's Codemods that'll convert from CoffeeScript to ES6, so I guess all kinds of stuff. Yeah.
So since it's writing out from the abstract syntax tree, what does it do with the formatting? Is it going to format it however it feels like?
Yeah, great question. So one of the tools that JSCodeShift uses is Recast, and I think Recast is also responsible for getting it from the source into the AST, but then it also puts it back, and it's really smart about putting everything back where it belongs. So one of the things, if we uncheck hide location data, you can see it's got start and end, which is You know, so it knows exactly where it was in the file, and it can put stuff back in the right spots, which is pretty cool. Anything else?